Hello, greetings to everyone. This is Rehan Jaffrey from Pakistan, a biomedical graduate from Sir Syed University, and currently working as product executive, diagnostic imaging and Shirazi trading company. I'm going to cover wireless electroencephalography based blood pressure monitoring with contents that includes background, motivation, abstract, methodology, results, and conclusion. One thing I would like to share here before moving forward that this project is basically an extension of my previous work, which was named Wireless Brain Computer Interface for Smart Home and Medical System, and got published in Springer's Wireless Personal Communication back in 2018. Forward with the background, a little bit about that how it works out. So it's a very basic illustration to explain what is PCI, how brain is interfaced with the machine. So here you go. It is very self-explanatory that this device is basically an interface which is used to connect your brain with the machine or computer. Are very trending and few of many examples of PCI, which is brain controlled gaming and brain controlled wheelchair. Here you can see the 10 by 11 system of EEG cap is used to control the virtual object and hence a pure controlling of your virtual games. On the contrary, the brain controlled wheelchair, you are using the whole wheelchair movement, left, right, front, forward, backward, just by 10 by 11 EEG cap. We have many more examples of BCI, but these are very training examples actually. So let's talk about some motivation that behind my project. What was my motivation? What was the motivation of my team to work on BCI, to work specifically for blood pressure monitoring? There are a few daily observation that I with my team found to work upon, which is for the physically handicapped patients, bedridden patients, and elderly patients who got dependent at the later stages. They always require someone to help them out in their daily routine to make their lives independent is my aim of this project basically. So let's talk now about my project and the abstract, that what is it about actually. So here I use the EG headset, which is commercially available for research and education purpose. I basically connected this headset with my smartphone by designing a small interface which controls these two blood pressure monitor. I would like to tell here that the basic aim of this extended project is to gauge the precision of my system, of my prior system. Initially, I used one blood pressure monitor there on that was placed on the wrist, but the readings that I got from that were a bit deviated from the standard readings taken from other standard and oscillatory blood pressure readings. So to gauge those deviations, to reduce those mm, you know errors, I compared the two blood pressure monitors. One is placed at the wrist and one is placed on the upper hand by using the same system, obviously by after some modifications. So this is what I have done, that through your brain you can control these two blood pressure monitor one at a time or both at a time, and simultaneously monitoring their data on the smartphone. And the smartphone application is also my patent that I have personally designed by myself. The whole transmission, the whole connectivity is basically a wireless, which is under the range of 10 meters, that you will see how and what means of transmission I used in my project. So this is a very core and major part of the project, which is the methodology. My methodology is based on the three steps. Starting from the first step is to connect your headset to mobile controller of the system. In the previous slide, I mentioned that I have designed my own interface. Here, I have named that interface is a mobile controller. So by a mobile controller, you should click on that it is the self-designed interface. So the first step is the built-in Bluetooth of the headset pairs with the first SC05 Bluetooth module of a mobile controller. In my mobile controller, I use two different Bluetooth modules of HC05. One HC05 is connected to the headset. In headset, it has its own Bluetooth. So in my interface, one HC05 is used to receive data from EEG headset wirelessly within the range of 10 meters as shown here. And my first Bluetooth module is wired and connected to Arduino UNO. That is obviously required for its own configuration. So here is the first step, that how EEG headset is wirelessly through the use of Bluetooth is connected to my Arduino UNO. Here as a microcontroller, I use the Arduino UNO to make programming to regulate things. First is the headset interfacing. There is a part of programming which involves the headset interfacing. The other part involves the data transfer to the phone. The third part involves the detection of eye blink and the attention level detection. So this is the segregation of my programming or my protocols in the Arduino. Let me explain how things are going inside our Arduino. First of all, the data I am getting from the headset is basically of two useful information. The data comprises two useful information. One is the eye blink detection, the other is the attention level detection. So the headset which I am using can get you an information for your eye blink and your attention level, and these two parameters I acquired as a source of input signal to control and operate my two blood pressure monitors or any medical devices you may want to. And simultaneously, the data is transmitting to the cell phone, carrying some useful information which you will see ahead for the monitoring purpose. One more thing which is kept in view, that how eye blink is useful in my project and how attention level is used in this project. The eye blink detection is basically used to select the PP monitor which you want to operate. Once you select the appropriate device, the attention level is used to control that selected monitor. How would it work? Let's see in the next slide. So, continuing the second step, which is a different view of the second step for sure, and that is the software architecture, that how programming goes on in the Arduino, how we program the Arduino to make a cycle. So as you start the project and turn the button on of the project, the programming starts by giving you 8 seconds for your selective eye blinking. The system will give you 8 seconds to select a device, and we have configured the system by our own choice. For example, blink one time will select you the wrist PP monitor. Blink two times will select you to control the arm PP. And if you blink three times within 8 seconds, both PP monitors at the same time are selected and ready to be operated later on. Once the 8 seconds is over, the programming will ask or will see, is the selected devices initially off? If yes, then the user will require to achieve his attention level between 60 to 70. As it achieves, the selected device will get on because it was initially off, and that's what here it is asked, that is selected device initially off or not. If it was initially off, no, then the selected device is initially on. Definitely device must be either on or off. If it's off, it will go right this way, and if it's on, definitely then it will move to this way. So if the selected device is on and you are supposed to make it off, then you have to raise the tension level between 70 to 80. And as this attention level is achieved, the selected device will get off, and then the cycle continues. Again, the Arduino will give you 8 seconds to select the device again to control it. One fact I would like to mention here, the attention threshold range, which is 70 to 80 and 60 to 70, we have decided by our own. We have configured it by our own. Normally the human attention level can't be reachable above 50, and that's the reason why we make this threshold, to make the devices on or off. In the normal human brain state, our attention level goes around 30, 40, 45, but to achieve this level, to achieve this threshold levels, which is 60 to 70 and 70 to 80, user will have to draw his attention deliberately towards thing to get it on and control different things. So that's the beauty of the project, that's the beauty of the brain actually, that we utilize it to make this system. Now the third tab is about a smart home monitor, which is an Android application. We have designed this application on MIT App Inventor tool, which is readily available on internet. Definitely the purpose of this application is to make the project user friendly and and it's for the monitoring purpose, for the ease of the user, because for this project our targeted user is basically the handicapped patients, the old age patients, the old age persons, bedridden patients, as I have shown in my motivation earlier. So what information does this Android application basically keep in itself is shown in front of you. The number one button is the connect or disconnect button. This button is used to connect the Bluetooth with the headset. I'm sorry, this button is used to connect with my interface because phone is wirelessly connected with my interface and my interface is wirelessly connected with the headset. As you click the button, here the connected status will change. If you disconnect it, here it will be written the disconnected status. The number 2 point is the attention level and the strength of the signal that you are getting from the headset. So basically the threshold ranges that I was talking about in the previous slide, which is 60 to 70 and 70 to 80, is this number actually. In the normal state, I have mentioned earlier that the brain attention level revolves around 37, 35, 45. So here this is the basic signal which you are getting from the brain via EEG headset. And poor quality shows the strength of the signal. Poor quality is equal to 0 shows the strength is very high and there is no drop in the signal. The third point is instructions. Instructions are basically uh, the enclosed programming that we have programmed or configured the Arduino to work like. For example, on one blank, the wrist BP will select. On two blinks, the arm BP will select. On three blinks, both BP can be operated at the same time. So here it will, those instructions will be shown here. But you here for this specific snapshot, you can see there is written fan light. So again, I would like to share here that this snapshot is taken from my previous original work. In that work, I have controlled the BP fan light and the therapeutic belt. So don't boggle with these instructions to the actual instructions of the project. The fourth point is the detection status. The detection status will show you how many blinks you have made so far and what application is going to be selected. So if I consider this instruction as a reference, blink more than 3 times, or if you make no blink, the therapeutic valve will get selected. So here you have just done it and the detection status just detected and shown here that the user have blinked 4 times and it is detected, which is written here, and the belt routine is going to be selected. So this is what the Arduino is telling the user that what is going on in itself. The fifth point is the appliances status, that what devices are currently on and what devices off. So this is all about the data monitoring, a smart home monitor Android application, which is obviously Bluetooth based and for user friendliness. So this is the whole picture of our three-staged system design. That EEG headset is connected wirelessly to Arduino through one Bluetooth module, and the Arduino operates two blood pressure monitor devices and simultaneously transmitting data to a smartphone application. Now the result that you all have been waiting for since it's a long presentation. So here we go for the result. So after designing the project, we have implemented this project on several individuals of different ages. For this extended project, we have implemented 10 to 20 individuals to analyze different parameters, market acceptance of this project, and of course the very basic and the critical and the main aim of this project, which was to increase the reliability and reduce the error of margin, which was in the previous project. So, in blood pressure, of course. So basically, this is a comparative analysis between the readings that we have got from wrist BP and the arm BP, and we have compared the systolic blood pressure of wrist with the arm. Likewise, diastolic blood pressure of the wrist and the arm. And here you can see very clearly that standard deviation of the arm BP is comparatively low than the wrist, and same goes to mean systolic blood pressure, and mean systolic diastolic blood pressure. So this clearly defines that what should we conclude through this statistical analysis, get a more clear picture into which is the essence of this whole project. So here we go very quickly. The following benefit that we get it from this extended project is controlling of medical devices by user attention and eye blinks, which obviously help the handicapped patients to make their lives independent. The whole system is wireless, battery operated, and rechargeable, which obviously gets light in weight for them to use it. Portable when the range of 10 meters reduces the hassles of long wires, like in the 10 by 11 system that allow that abducts the patient to and to not allow to mobilize. The fourth point is it allows to monitor useful information on a smartphone. Of course, modified design makes the system more handy. This is one of the aims of this project basically. Previously, our system was a bit bulky, so we almost reduced one big part, and the system now is now very handy just by redesigning and remodeling. And after redesigning and remodeling of the system and reducing different electronic components, obviously we have got a very better battery consumption, and systems precision get better as well. So to this point, from the first one, these all are the changes and benefit that we get it from the hardware perspective. But now if I talk about the statistical analysis basis, so what we have got from the previous chart, here you go. Mean systolic blood pressure of upper arm that we have got 119.6 mmHg is better than the mean SVP of wrist, which was 128.2 mmHg, and DPP, which is the diastolic blood pressure of upper arm, which is 79.5, obviously is better than the diastolic blood pressure of wrist, 83.6 mmHg. So the results are in front of you now, and these results are what we get from after performing the analysis of several individuals. The last point, the standard deviation values of arm, which is SBP plus minus 5.1 mmHg, and DBP plus minus 7.4 mmHg, are comparatively lower than the standard deviation values of wrist, which was 11.7 mmHg and 10.3 mmHg, thereby indicating the upper arm BP to be more precise. So these points are basically takeaways for you after listening me a lot. This is the last slide, which includes few of the important references that you will also find in my submitted research paper. And the last YouTube link is the uh, working of my project, that if any one of you is interested to watch, so you can follow this link to have a more view of my project. Thank you very much, everyone, for your kind attention. God bless you all.